thank you. So we are with Tim Kolbe, and we are discussing the paper titled Which Knowledge is Required in Exams of Real Analysis 1 Courses at German Universities. And your co-author is Michael Levendorfer. And while you were writing this paper, you were both at the University of Paderborn. Okay, thank you for agreeing to this interview, Tim. So the first question I want to ask you is, can you briefly describe what this paper is about?
Yeah, so first of all, thank you for inviting me to this interview. And I would gladly talk about my paper, which is about the types of knowledge required in Analysis 1 exams at German universities. And for that, we are using the theoretical background of procedural and conceptual knowledge. And based on this, we developed a coding scheme to analyze exam tasks. And in our coding scheme, we use 5 categories, which are recall, procedures, concepts, and between procedures and concepts, we have a type of knowledge that is supported by the other, which means procedural supported concept, for example, and vice versa. And with these 5 categories, we analyzed 49 exams across 12 of 16 federal states in Germany. And usually the Analysis 1 courses are taken by mathematics majors and prospective secondary school teachers in Germany.
Yeah, that's very interesting. Something that I found really interesting is the overlap between procedural and conceptual knowledge, and the 2 categories that you developed. Can you talk a little bit more about these 2? Because I think these are very important.
Yeah, so first of all, we found in the literature that it's not so easy to distinguish these types of knowledge. And when we analyzed exams, we also found it very hard to put one task in procedural or conceptual, especially when we're looking at tasks from university, because they're typically a bit longer, a bit more complex than school tasks. And so there are tasks that require where we thought, well, this is procedural knowledge, but there's one step or one type of conceptual knowledge as well that is needed for the solution. So for these kind of tasks, we thought it might be better to have some kind of mixed knowledge type. So where we thought, well, this is most likely or more or less a procedure, but there's some steps or some small supporting part of conceptual knowledge.
Okay, so the second question is, so which are the key findings or outcomes of the research presented in this paper?
So we had 2 research questions, and this is what I'm focusing about. The first one was to find out which knowledge is required to solve these tasks, the exam tasks. And with our categories, we found out that all of our knowledge conceptualized is needed or required. However, the procedural knowledge is dominant in this, with 42% of all tasks that could be solved solely by procedural knowledge. And the other tasks, other categories are about 10 to 15%. And we also wanted to find out which knowledge is sufficient to pass exams. And in 43 out of 49 exams, students could have passed by relying only on recall, procedural knowledge, and procedures with the support of a bit conceptual. And so there's not really a substantial conceptual insight needed. No, I wanted to go on for our discussion part, or we discussed that there might be, with this results, a mismatch between teaching and assessment, where we think that usually these courses head for deep understanding, which is most likely conceptual knowledge. However, in the assessment, it's more focused on procedural knowledge.
Okay, so following from that, what insights or lessons can we derive from your paper for the teaching and learning of mathematics?
Yeah, so first of all, I think if all students had the information of this paper or similar papers, they would probably focus learning heavily on procedural knowledge, since this is sufficient to pass exams, and they wouldn't focus their learning on deep understanding, because it might be harder to understand these complex concepts in mathematics. And for that, I think instructors could consider including more tasks that target conceptual reasoning or conceptual understanding. Um, for example, changing task formats to ask maybe for examples, counterexamples, explain typical errors in a solution, or find or interpret steps in a proof. That doesn't all have to be constructing proof task formats in an exam, or might as well think about a different exam type, for example, oral exam, which Joanna has a lot of scientific research in.
Yeah. I don't know the German context, but I can speak for the Australian students. And the students that I teach, which are first year, and I teach calculus, I don't teach real analysis. They would find it really hard to answer conceptual questions in an exam. How is it in Germany? Do you think that they will struggle with more conceptual questions?
I actually think when it's only about constructing proofs, yes, I think it's very hard. And it showed as well when I was studying that these are the tasks that are the most difficult for students. But I think if we prepare the students more for like showing examples, counterexamples, what I talked about, then it could be a bit easier to for students and might be a bit more have an impact on long-term learning.
Yeah, definitely. Thank you very much. This is, as I said, very short interview to so that our readers know a little bit more about your paper, and hopefully they will go and read the whole paper themselves.
Yeah.
Thank you very
Thank you so
much.
much.